Welcome back to our second day of working with these rational functions. So, for these rational functions, we're going to use the exact same ones we started yesterday and now finish the process. Okay, that's what I'm going to do for your practice work as well. Okay, so, excuse me. So, I'm going to give you the exact same function. So you already have half the work done. So today won't be as daunting. Then tomorrow, we're going to focus on how do we go through this process the entire way through. So looking at these. So this is the exact step-by-step process. Now, I'm not going to sit here and read it to you because I'm sure you can read it yourself. But this is a place to reflect that if you ever get lost in the process of what's happening, this is where you can go to look at it. And then I've shown you some kind of cool pictures of these are the types of functions that after today and tomorrow, you're going to be able to make and you're going to be able to graph these things, which they look really cool. So let's go back to our first example from yesterday. So y equals 5 over x plus 2. So let's take a look at what we already know, okay? We talked yesterday about a horizontal asymptote being at x equals -2 and a horizontal asymptote at y equals 0, okay? So we already have part of our battle won, okay? So now let's take a look at the rest of this, all right? So what we still need to know. So this is our new focus of today. To find the x-intercept, we're going to set the numerator equal to 0. Well, in this case, that doesn't really quite make sense because the numerator is just a number. 5 will never actually be able to be 0, so there is no x-intercept, which actually should make sense to you because notice the asymptote is on the x-axis. So how could there be a point on it if that's where my asymptote is? So that actually should make sense to us. The other point we're going to try to find is the y-intercept. The y-intercept is where we plug 0 in for the x's of the function. So 5 over 2 is about 2.5. So my y-intercept is at 0, 2.5. So I have a point right there. Once you label those 2 points, what I'm going to allow you to do is actually go to your calculator and type this in. All right, so after you find the points, after you find the asymptotes, and after you find those special points, I actually want you to go and I want you to plug this in to the y equals. Excuse me again. So actually plug in 5 divided by x plus 2. Now note I'm putting parentheses around the denominator, so it knows I'm dividing the whole thing. And hit graph. Oh, excuse me again. I apologize. The reason I'm having you graph this is because it would take you way too long to make a table for this. So once you find me the asymptotes, once you find me the x and y intercepts, if there are any, use this to finish off your graph because now you can see where your branches are. And so you can just sketch them in for me at this point. All right. I know I have a branch in this quadrant. And I know I have a branch down in this quadrant. And that is what your graph looks like. All right, so it's really not as daunting as it seems. You just have to know each piece to get each step along the way. All right. So let's move on to our next one. So here we have this function. Again, we've already simplified it down to that x plus 3 divided by, or x plus 6 divided by x minus 3. I know I have a vertical asymptote at x equals 3. my horizontal asymptote at y equals 1. We discovered both of those yesterday. And I'll get back to that hole at x equals 4, okay? So now let's work on gathering the points that we need. So the x-intercept. The x-intercept is where I set the numerator equal to 0. So there's my simplified numerator, and I'm setting it equal to 0. So my x-intercept is when my x is negative 6. Y-intercept, I'm going to plug in 0 for x. And again, I'm going to use my simplified expression. 6 divided by negative 3 gives me a negative 2. So my y-intercept is down at 0, negative 2. And what about that hole? So the hole is sitting at x equals 4. All right? Now I've already removed that from the equation. So if I put that 4 into my simplified equation, that is going to tell me where the hole is. The hole is sitting at 4, negative 10. So wherever the hole is, I want you to put a circle. Okay, you do need to indicate that hole to me because that is another point of discontinuity. So once you have all of those pieces, again, what you can do is just plug it into the calculator. So I'm going to take that, plug it in. So I have x plus 6 divided by x minus 3, graph it, and there you go. There is our function. Now, something you may notice, again, this is a really good thing because you may notice there's a mistake that I've made. All right? I didn't put the hole in the right spot. That is a positive 10. Now, how did I find that mistake? By using the graph. Okay, that's why the graphing calculator is so important because there are a lot of steps here that you can easily make mistakes, and I want to show you that the calculator can help you avoid those. Because if you see something in your work that isn't matching the graph, what that means is you should go back and see what did you do wrong. And here it showed me that I put the wrong hole in. But now that I have it right, now I can connect it up and I'll have my function. All right, let's move on to our next one. So here, what we already know that we have a vertical asymptote at x equals negative 4 and a horizontal one at x equals 0. And then we'll come back to that hole in just a moment. All right, so what we still need to figure out, we need some points. So we need the x-intercept, so set that simplified numerator equal to 0. Well, this is another one of those circumstances that you actually don't have an x-intercept then, because 2 will never equal 0. So I don't have an x-intercept. And to find the y-intercept, I plug in 0 everywhere for x, which equals 0.5. So my y-intercept is at 0.5. So about right there. And now for the hole. Again, if you go and you plug that x value into here, into the simplified one, I'll have my hole at -2, 1. So I'm just going to go and I'm going to put my open circle there to indicate that is where the hole is. You do have to note that that is a point of discontinuity. Now that I've done that, now let's go to the graphing calculator to check to make sure I've done everything right so far and to check that my branches are going to end up in the right spots. So 2 divided by, then I need to put parentheses around that x plus 4, graph it, and that represents where my 2 branches should be. So let's go and add in my branches. And there you have it. All right, so let's just move on to this one. So this one is rather unique. The reason I say that is because it actually simplified down to something you already know. You know how to graph y equals -3x. All that is a straight line through the origin. Okay? So you actually already know where that is. Okay? You know that it goes through the origin, has a slope of -3. And that's reflected in having no asymptote or no vertical or horizontal asymptotes. Well, what about this hole? Well, unfortunately, the hole, if I plug that 4 in, my hole is actually off my graph. My hole would be somewhere down here. Okay, so this time I actually don't even get to represent the hole because the hole is actually off of my graph. But for this one, I'm going to simplify down to just a straight line. Don't feel like you have to do all of this extra work. You know how to graph a line, and then just check the hole to see where that is. Okay? But don't make extra work for yourself that you don't have to do. Okay, in this case, you know how to graph a line, just do it, and then see if the hole is within the window of your graph. And finally, our last example. So here, again, very nicely, we already have our simplified version that we're working with. We already know a few things. We already know we have a vertical asymptote at x equals -3, a horizontal asymptote at y equals 2, and we know we have a hole at x equals 3, which we'll get to in a little bit. All right, x-intercept. So the rest of the things we need to know. X-intercept, set the numerator equal to 0. So 2x equals -5, x equals -2.5. So my x-intercept is right here, 0, -2.5. My y-intercept is where I plug in zeros for my x's. So 5 divided by 3 is about 1.7. It's 1.6 repeating. So my y-intercept is about right there. And as for my hole, let's plug that in. So I get 11 divided by 3, which is going to be about 3.7. So my hole is at 3, about 3.7. Again, it's technically 3.6 repeating. So 3.6 repeating, that's going to be right around there. And actually, all right, so let's take a look at this. So let's type in our equation. So we have 2x plus 5 divided by x plus 3. All right, so that is where our branches are, or where our branches should be. All right, so let's see if that matches what we found. Now, this branch is going to make sense. But again, this whole doesn't. So again, if you think you've made a mistake, go back and check your math. What happened there? Well, if you go back and look at the math to see that it's not matching, you should notice that this should really be 11 divided by 6, not by 3. You get about 1.8. So again, that graph is a really great way to check to see if you've made a mistake, because it is super easy to make mistakes in this. Okay, so let these graphs help you. So you can go back and see, oh, that whole didn't make sense. I'm going to go back and I'm going to check my numbers to see that it does. And now my whole matches where the rest of my graph is. Now again, it's a little bit hard to tell, so just make sure you realize if it accidentally looks closed, just go and note that it's a hole, because you do want to have an open circle there. And again, my markers for my smartboard are a little bit thick, so it's difficult to sometimes see that I'm actually indicating a hole there. So, all right, deep breath. I know that this is kind of a lot to take in, but again, at least today you're only doing half the work. Half of it we already took care of yesterday. So, again, just reflect a little bit on that process. Write me a summary of how you're going to remember what steps to take to get through this, and then come back ready to do your practice work.